Hello everyone. So in earlier videos I talked about the spontaneity of the reaction. It depends on the energy and entropy. So these are the two factors which affects the spontaneity of the reaction, isn't it? So these are not the only criteria which decide the spontaneity of the reaction, because we observed that the reaction can be exothermic and can be exothermic or endothermic, but still they can be a spontaneous one, isn't it? Now if the number of gas molecules or the entropy is increasing or decreasing, still the process can be spontaneous. So what is the third thing which is involved to decide the spontaneity of the reaction? Here comes the second law of thermodynamics, which says that total energy of a system and its surrounding increases in a spontaneous process. What does it mean? It means that the system which is at low temperature, means I'll explain with some simple examples. If the system is at low temperature like 2 degrees Celsius, and if you remove heat from it, if you are removing heat from such a system, remove some heat energy from this system. So as you know that delta S is equal to Q reverse upon T, isn't it? Now this delta S is quite related or inversely related to this temperature, isn't it? So entropy is inversely proportional to temperature. So the delta S value will be greatly affected when you remove the heat from this 2 degrees Celsius. Means already this is at lower temperature, and from this lower temperature you are removing the heat. So this delta S value will be greatly affected. But if you are having the system like a temperature having 5000 degrees Celsius, and if you are removing some heat from this, so the value of delta S will not be greatly affected as it was in this earlier case. Means if a person is having 10 crore of rupees, and if you are asking for 1 rupee, so it doesn't affect him a lot. But if a person is having 5 rupees and if you are asking from him 2 rupees, so the person will be greatly affected. Similar is the case here, isn't it? So this is this entropy is quite related, inversely related to this temperature also. So the heat will flow from the system which is at high temperature to system at low temperature. So ultimately we have to think that entropy of the system and surrounding increases in a spontaneous process. Remember, what is this second law? This is the total energy of a system and its surrounding. So here comes the third thing, that is the surrounding. We had not talked about this entropy or energy of the surrounding up till now. So whatever the heat is released, whatever the amount of heat is gained during any heat changes or energy changes, so that must be either gained by the surrounding or given by the surrounding. So this surrounding is again plays a very vital role in deciding the spontaneity of the reaction here. So you can further write as, that is delta S total, means the entropy change of the system and entropy change in of the surrounding. Addition of this will give you the entropy change, that is total entropy change. If it is greater than 0, then the process would be spontaneous. For example, I can quote the example here. Twice H2 in gaseous form, it reacts with oxygen in gaseous form to form twice H2O in liquid form. So delta S for this is 327 joules per Kelvin, and another value we are having, delta H equals to minus 572 kilojoules here. So this is enthalpy change. So negative sign indicates that heat is released in this case. So heat is released here, and in the earlier one, this is the negative sign, means it suggests that there is decrease in entropy. So entropy decreases here. So to find the total delta S total here, we need to know the entropy change of the surrounding here. So when 2 moles of H2 and 1 mole of O2 gas combine to form 2 moles of liquid water, 527 kilojoules of heat is released here. 572 actually. This is 572 kilojoules of heat is released, which is received by the surrounding at constant pressure and temperature. So this is the enthalpy. Up till now we were saying that either the heat is released or heat is absorbed, that is nothing but the delta H. So if the heat is released, so where will it go? It will be absorbed by the surrounding. So when you want to know the total entropy change, you will have to take into account the entropy of the surrounding also. So delta S surrounding can be written as here will be equal to Q reverse upon T, which is equal to 572 into 10 raised to 3 joules. We will be converting it into joules at temperature 298. So it comes out to be 1990 joules Kelvin here, isn't it? Here it was given a negative sign to this heat is released. So when this amount of heat release, it will be absorbed by surrounding, so it will be having a positive sign here, isn't it? So here you will get the answer, that is 5 minus 572 into divided by this 1990 here. Now when you want to find out the delta S total, so that will be delta S system plus delta S surrounding. So it would be minus 327 joules per Kelvin plus 1919. So it comes out to be plus 1592 joules per Kelvin. This is the total entropy change of the system. If this delta S total is greater than 0, means you can write here only, I will make some space here. If this delta S total is if it is greater than 0, then the reaction is spontaneous. Reaction would be spontaneous. So we need to follow entropy of the system and surrounding both if you want to decide whether the reaction would be spontaneous or not. So we will come to some conclusion here. Now if the delta S total is greater than 0, the process would be spontaneous. Okay. Now if delta S total is less than 0, the process would be non-spontaneous. And the third case may arise if the delta S total equals to 0, then the reaction or the process would be at equilibrium. Thank you.